Hi, this session is on practice test questions and our topic is on number skills. Our first question asks us to round off the following number to the leading digit, then the nearest thousand and nearest hundred. So let's do this one first. And I forgot to mention, please have a go first before you check the answers. Okay, so to round off to the leading digit, remember leading digit is the first number or the first digit. In this case, it's 3. So this is our leading digit. And so we have to, before we round off, okay, I can't just say, okay, so the whole thing is going to be 300,000 because that will be wrong. Okay, before you round off, you have to check and see, okay, there's my leading digit. The number after it is an 8. And remember, if it's 5 or more, you round up. And if it's 4 or less, you round down. Okay? So with this one, because it's 8, that 3 is going to turn into a 4. Or add a 1 to the 3. So the correct answer you should have had was 400,000. Okay? Is the leading digit. Okay, the next B asks us to round off to the nearest thousand. So remember, your first step is locate the thousands column. So we've got ones, tens, hundred, thousands. So 2 is in my thousands column. So I know my answer. This 3 and 8 is going to be my answer. Whoops. There we go. It keeps disappearing sometimes. That's going to be my answer. But I have to check and see now, am I going to round up or just round down? So let's have a look. So 2 is in my thousands column. The number after it is a 5. Because it's 5 or more, I have to round up again. Okay, so add a 1 to that 3, add a 1 to the 2, and I end up with 3. And you can see I've got 3,000. I've rounded up. So that's my answer. So hopefully you had that. The next one is to the nearest 100. Once again, I'll just change my color. We'll go blue. Okay, so nearest 100, go to the hundreds columns. So ones, tens, hundreds. There's my hundreds column. So I've got 561. So everything before it is going to be there. So I've got 3, 8, 2. Okay, and now I'm going to check and see, am I going to round up or round down? So let's have a look. The 6 is next to the 5. Because it's 5 or more, I have to round up. So add a 1 to the 5. 5 plus 1 is 6. So I've rounded up and there it is, my 600. And everything else on the end becomes 0. Okay, so that's how we round off to a specific place value. Okay, our next question involves fractions. So have a go first and make sure you apply your fraction skills. So with the first one, I can see I have division. So your first step is check and see your operation. Because I have division and fractions, I know I've got to turn that into times. Okay, that's going to be one of my steps. Also, I can see I have a mixed fraction. I'll turn that into an improper fraction. So we'll do that one first. To turn a mixed fraction into improper, we have to go times and then plus. And the denominator does not change. So 4 times 2 is 8, and 8 plus 3 is 11. Times, I'll do this now. So I'm going to turn division into times. To turn that into times, I have to flip the second fraction, or the fraction on the right hand side. So now I end up with 8 over 1. Okay, so now I've got multiplication. And now that we're multiplying fractions, remember, simplify before you multiply. Okay, I can see I've got a 4 on the bottom and 8 on top. We can simplify anything from the top and the bottom or bottom and top. All right, so divide by 4, I get a 1. 8 divided by 4 is 2. There is nothing else I can simplify. I'm going to now multiply across. 11 times 2 is 11. 1 times 1 is 1. So 11 times 2 is 22. 1 times 1 is 1. So my final answer is 22. So hopefully you had that. Just check and see if you made a mistake somewhere. Okay, the second one, our operation is addition. Oh, it disappeared. So when adding fractions, we have to have the same denominators. Okay, that's really important. Or adding and subtracting fractions. So I've got a mixed fraction here. I will first turn that into improper. So 5 over 10 can stay the same. Plus 2 times 2 is 4. Plus 1 is 5. So 5 over 2. And now let's turn our denominators to be the same. The lowest common denominator for this one, I think, is 20. So I'm going to times 2 by 10 and 5 by 10. And 10 multiply it by 2 and 5 by 2. So I end up with 5 times 2 is 10 on top. And then 5 times 10 is 50 over 20. Now I can add these because they have the same denominators. So 10 plus 50 is 60. And I end up with 60 divided by 20. I'll just squeeze it in here. So 60 divided by 20. I'll cancel my zeros. And now I've got 6 divided by 2. So your answer should have been a whole number 3. Our next question asks us to calculate, so we're calculating this, 2/3 of $60. So have a go first. Now, when we have an oven maths and dealing with fractions, or trying to find an amount of something, of becomes times. That's really important, okay? It's a key word there. Trying to find an amount of something, we turn of into times. So I end up with 2/3 times. Now I'm going to ignore the dollars for now and just write 60 over 1. This is part of my working out. And my final answer, I'll make sure I put the units back in, the dollar sign back in. Okay, now multiplying fractions. Simplify before we multiply, if possible. All right, I've got 2 and 3 can't simplify, but the 3 and the 60 should be able to work. 3 divided by 3 is 1. 3 into 60, well, 3 into 6 goes 2 times. And 3 divided by 0 is just 0. So I end up with my 20 on top. So to make it neater, I've got 2 over 1 times 20 over 1. Which is, and then multiply across. So 2 times 20 is 40 over 1. So my final answer is $40. So put the dollar sign in your final answer. So 2/3 of $60 is $40. Okay, our next fraction looks more complicated, but it's just as easy as the other ones, as long as you do it step by step. And don't forget to apply BIDMAS, order of operations. So with this question, I can see I've got to turn this mixed fraction into improper. But I've also got different operations. I've got a takeaway or subtraction. I've got multiplication and division. Now I know multiplication and division come first or come before the subtraction. So I'm going to put a bracket around this part here to say I am doing that bit first. I'll leave the subtraction till last. And we know that multiplication and division, they are equal, which means neither comes first. So we just work from left to right. All right, so, and on my next line, I'll also change this into an improper fraction and get that out the way. So 4 times 1 is 4, plus 1 is 5. So here I've got 5 over 4, take away, okay? I'll keep my brackets there just to emphasize I'm working in these brackets that I've put there. Now, left to right, so 2 over 3, or 2/3 times 9 over 5. So simplify before we multiply. So divide by 3 there. 9 divided by 3 is 3. There is nothing else I can do, so I'll stop there. So just to emphasize, I'm doing, if I put another set of brackets in here, whoop, it disappeared. I'm doing that bit first. Okay, I'll do division later. All right, and that was cancelled out. So I end up with 2 times 3 is 6 over, and then 1 times 5 is just 5. So this whole thing is over there is now gone. I've multiplied them together. I ended up with 6 over 5. And bring this back down, divided by 1 over 5. Okay, that's really important, that everything in the question comes down. So you can see how each line has the whole question in there, and the changes that we make happen step by step. So I still have my 5 over 4 that I haven't worked with yet. I've still got the division that comes first. So I've now got 6 divided by 5, 6 over 5 divided by 1 over 5. That's going to turn into a times now, the division. Okay, so I've got to flip the 1 and the 5. So I'll do it down here so it's clear. So I've got 6 over 5 times 5 over 1. Okay, if you don't want to use brackets, you don't have to, but I put them in there to show myself that I'm doing that bit first. Okay, so don't forget I'm still working on multiplication because that comes first. And now cancel my 5s out, simplify before we multiply. And now I end up with 5 over 4, take away. I've got 6 times 1 is 6, over 1 times 1 is 1. So I'll continue it up here. So I now have 5 over 4, take away 6 over 1. Now I can do my subtraction because everything else is now taken care of. Now, when subtracting fractions, we have to have the same denominator. I've got a 4 here and a 1. I know I can turn my 1 into a 4 just by multiplying it by 4. So I now have 5 over 4, take away. 6 times 4 is 24, divided by 1 times 4 is 4. Okay, now with this question, we are going to end up with a negative. You don't have negatives on your first test tomorrow, but don't worry, we can still work this one out. So 5 take away 24, well, as normally, we'll put the 4 there ready. What is 24 take away 5? It will give me 19. But because I started with a small number, it's actually negative 19. Okay, and now this negative can just sit on the outside because it's just saying the whole thing is negative. And we'll look at this in more detail later on. And now turn this into a mixed fraction. So 4 into 19 can go 4, 8, 12, 16. So 4 times and remainder 3 over 4. Okay, so there's my final answer. If you didn't have the negative there, that's okay. We haven't learnt negatives yet. Next question is asking us to multiply these two decimal numbers. So please have a go first. Now we're multiplying decimals, or a number that contains a decimal. We ignore the decimal. That's our first step. So this number without a decimal will be 2,101. And without a decimal, 3.2 is just 32. Okay? We'll take care of our decimals later on. So multiply this out. I'll do it up here so I have some room. So 201, whoops. So 201 times 32. Set up your multiplication algorithm. And we'll do this as we normally do. I'll just change my color. So we have 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. Please make sure your numbers are in their right place value, the right column. All right, when we go to our 3, we know 3 is 30 in the tens column. So I have to add a 0 here to push myself in the tens column. Now 3 times 1 is 3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 2 is 6. Okay. And our final step is to add up these numbers. So 2 plus 1 is, 2 plus 0 is 2. So we got 3, 2, 7, and 6. Okay. Now, I'm going to write it over here because we have not finished just yet. Now, don't forget, we ignored the decimals. And now we have to put it back in. And if you remember in class, to do this, we have to count how many decimal places are there in the whole question. So how many numbers are there after the decimal? Here, I've got one number after the decimal. It was 2, so that's one number. I'll just leave it like that. And then here, I've got another 2, so 1, 2. In total, I've got 1, 2, and 3 numbers after the decimal. Now, in my answer here, my decimal point is sitting right there. I've made it visible. Now, I have to bring it back 3 times because in my question, I had 1, 2, 3 decimal places. So I have to go 1, 2, and 3. And it disappeared. So my answer, sorry, I don't know why it disappeared. I'll just put it back in. So 2, 3, 2. So my answer is going to be, so let's move from there, 67.232. I don't know why that changed color. All right, so hopefully you had that answer. So don't forget, when multiplying decimals, you first ignore the decimal and then you do your calculation. But don't forget, you have to put the decimal back into the answer by counting how many decimal places there are and then moving it back. Now we are moving on to division. So I want you to have a go first. Now, when dividing numbers, you can write it in fraction form. I like to do this so I can see what my denominator is. So 2.813 divided by 4. Because my denominator is a whole number, I can just straight away set up my division algorithm. This falls down and goes under the bridge, if that helps. So I've got 2.813 and the 4 on the outside. Now get your decimal point ready above. And if you want to, add some zeros on the end to get that ready too. Okay, so now let's start dividing. So can 4 go into 2? No, so I've got a 0 out there. I'll change my color. So I'll carry the 2 onto the 8. Okay, so I've got 4 into 28. That can go evenly 7 times, so no remainders. 4 into 1, can it go? No. So don't forget to add the 0. This 0 is very important because it's in the middle, okay, of digits. So it's part of the question. It's really important. Carry the 1 onto the 3. So 4 into 13, so 4, 8, 12. Can go 3 times, remainder 1. Now 4 into 10 can go 4, 8, so 2 times, remainder 2. 4 into 20 can go 4, 8, 12, 4 into 20 can go 5 times. 4, 8, 12, 16, 20. And it stopped. So my decimal, this value here terminates. So state your final answer. I have 0.70325. And that's it. I added these extra zeros to help me work out my calculations. And I stopped at this 0 here. So this is a terminating decimal. And don't forget, if you didn't have that 0 in there, then you've made a mistake, okay? Okay, for our next question, we are dividing again. We can see both numbers are decimals. So if you look at this and you think, oh, it looks too hard, it's actually easier than the other one. So I'm first going to write it as a fraction. You don't have to do this, but I like to do it this way. Same thing, okay? Both are saying divide, but I can see clearly that the denominator has a decimal. It's 0.002. I need to turn that into a whole number if I'm going to divide this. Otherwise, it's too hard. So, to turn that into a whole number, I've got to times it by something that's going to make my decimal move 1, 2, 3 places. Oops, sorry. Okay, so to move my decimal 3 places, I have to multiply, because my number's getting larger, by 3 zeros. 1, 2, 3, or 1 and 3 zeros. So by 1,000. That will give me a 2 on the bottom. Okay? But what I do to the bottom, I must do the top. So I'm going to times the top by 1,000 as well. So timesing by 1,000, I end up with 1, 2, and 3. So my number is now going to be 8, 1, 2, 3, 6. So 81,236. My decimals are now invisible. Okay? Which is great. So, but the main one had to be, the one that really had to be a whole number was that bottom number, the 2. So set up your division algorithm. And this number here goes under the bridge just there, and the 2's on the outside. And now we simply start dividing. So 2 divided by 8 is 4. 2 divided by 1, can that work? No, don't forget the 0. Carry the 1 onto the 2. 2 into 12 can go 6 times, no remainders. 2 into 3, once again, it can't go, so add the 0. If it helps, you can cross off as you go. Carry the 3 onto the 6. 2 into 36. Sorry, excuse that, I made a mistake. 2 into 3 can go once. Sorry, I had a brain freeze. 2 into 3 can go once. Remainder 1. And then 2 into 16 can go 8 times. So your answer should have been this here. So 40,618. Okay. Whoop, that disappeared. 40,618 should have been your final answer. Now this question here involves order of operations, or what we call BIDMAS. So with this, we know we work with our brackets first. Now I have 2 sets of brackets, so make sure you work inside out. Your working out must be structured properly, especially if you want full marks in your test. So 1 equal sign per line and clear working out. So I'm going to work on this part here, my inner brackets. Now inside these brackets, I've got 3 take away 2 squared. What is 2 squared, or 2 to the power of 2? That must be done first. I know that is 4. Okay, and then I end up with 3 take away 4. So this one involves a negative, and that's okay. The test won't have negatives, but we can still practice with negatives. So 3 take away 4 is going to be a negative 1. So in these brackets, I'm going to have a negative 1. I will stop there to write out what I have left. So 2 plus 10 is still there, times, whoops, that's a times. I still have these outer brackets. Now I've got a minus 1 plus 4 inside my brackets. If you wanted to include the extra step that we just did, you can. I just haven't got enough room. Okay, I still have brackets. Now what is minus 4 plus 1? Well, that's going to be positive 3. So 2 plus 10 times, this whole thing is going to be 3. So times a positive 3. The positive is invisible, so it just times by 3. And now the last bit, don't forget times comes first. So if it helps you to identify that, you put brackets around what you're doing first or next. So 10 times 3 comes first. So I've got 2 plus 10 times 3 is 30. And finally 2 plus 30 is 32. So hopefully that was correct. And just remember, inside brackets come first. Okay, the next question, I think we're up to 10. I've forgotten what number we're up to, so I'm just guessing. All right, so this question asks us to describe these numbers. So look at the first one. I can see I've got 2 point, and then it's a 5, 6, 5, 6, 5, 6. And these 3 dots are telling us it's going to continue forever. If I wanted to write this as a final answer, I would have this 2.56 with a dash on top. That's saying the 5 and 6 will keep repeating itself forever and ever. Now, to describe these numbers, you have to use keywords. Some of the keywords we've learned are terminating, non-terminating, and recurring. So this one here, you can write recurring. This number is recurring. There's a pattern that's recurring or keeps repeating. Recurring also means non-terminating, but if you want to write non-terminating as well, that is correct as well. Non-terminating. But make sure you have recurring in that. Okay, number 2, let's have a look at our decimal places. Is there a pattern that you can see? 8, 7, 1, 3, 5, 1, 2, 1. There is no pattern. And these 3 dots are telling me it's never going to end. So therefore, to describe this decimal, at this stage, I will say it's non-terminating. Now, these numbers do have another name. I don't know if we've learned it yet. You may know it already. It's also irrational because there's no pattern. But at this stage, if you write non-terminating, you'll get full marks for that. Sorry, it disappeared. And the third one, 2.5, my decimal place stops, it terminates. So for this one, I will write terminate. It terminates. I know it's a negative, that doesn't matter. Look at the decimal, it's a terminating number. Now for our final question, which I think is 11, we will do an application just to make sure we're practicing what we learn in real life situations. All right, so you can write this down and try it first. So Tom buys 2.6 kilograms of apples at a price of $3.20 per kilo or per kilogram. Okay, so how much did he spend on apples to the nearest cent? So let's work the first one out together. Okay, so if it's 2.6 kilos and the cost is $3.20 per kilo, we just have to multiply this together to work out how much he spent. Okay, so we end up with 2.6 times 3.20, or I'm just going to write 3.2 because I'm going to first calculate it out. And the 0 doesn't need to be there at this stage. So ignore the decimals. So I end up with 26 times 32. So you can see our multiplying with decimal skills are coming into this. So 26 times 32, I will do it as an algorithm. You might be able to do it mentally, that's fine. So 2 times 6 is 12, put the 2 down and carry the 1. 2 times 2 is 4, plus 1 is 5. Okay, next column, add the 0 because we're in the tens column. 3 times 6 is 18, put the 8 down and carry the 1, there's the 1 there already. And 3 times 2 is 6, plus 1 is 7. Let's add this together. So I have 2, so 8, 9, 10, 11, 12, 13. And 7 plus 1 is 8. Okay, so I end up with 832. Now, you can't just stop there. That makes no sense to our problem. And we haven't actually finished the multiplying part. We ignore the decimals. So go back and see how many decimal places are there. We have 6 and 2. Remember, the 0 on the end doesn't count because that doesn't have to be there. That's just saying cents. $3.20. But when multiplying decimals, we ignore that 0. Okay? So, there are 2 decimal places. Right now, my decimal is here. Bring it back 2 times, 1 and 2. I end up with 8.32. Now, your final answer has to match the problem. So, your final answer obviously has to have a decimal point. A dollar sign. And then $8.32. The question said round off to the nearest cent. So in real life, do we deal with 2 cents anymore or 32 cents? No. So the nearest cent, I will have to round down because if it's 4 or less, you round down to 30 cents. So you should have had $8.30 as your final answer. Sorry, it disappeared. $8.30 is how much he spent. Another store charges $40 for 10 kilos of apples. How much do these apples cost per kilo? So we can see here, we don't know how much it costs per kilo, but we do have information to work that out. So to work out this one, you may have divided. So for $40 for 10 kilos of apples, if I go $40 divided by the 10 kilos, that will tell me how much it costs per kilo. So 40 divided by 10 is actually 4. Nice and easy. So it's 4. Therefore, the answer is $4 per kilo of apples. It's good to write a sentence when explaining a real life problem. So $4 per kilo of apples at this store. So to answer our final question, see which is cheaper to buy. Well, the first store is cheaper to buy. 2.6 kilos of apples at a price of $3.20 per kilo is cheaper than $4 per kilo. Okay, so hopefully that helped, and good luck with your test tomorrow.